Hey, Professor Davis with you as we move into Chapter 7, and Section 7.1 is on graphing qualitative data. Well, so far in this course, we've talked about linear mathematics, linear programming, and the math of finance, and now we're going to turn our attention to our final primary topic of statistics and probability. And we'll begin our study in the first two sections of Chapter 7 with the branch of statistics called descriptive statistics, in particular, graphical descriptive statistics. And to do that, we have to talk about the different kinds of data that we're working with. We can say that data, which can be placed into distinct categories according to some common characteristic, which is non-numeric, is called qualitative data. For example, if we would go through a college campus and write down the different numbers of species of trees on campus, you'd have a bunch of words, oak and maple and that kind of thing. There'd be a bunch of words. That's called qualitative data. I guess the more contemporary term for it is categorical data, because it's data which can be placed into categories and we can count how many of them, each of them there are. So that's going to be our focus here in this section, is on categorical, or in other words, qualitative data. Then in section 7.2, we'll take a look at what happens when we have numerical and computable data, and that's called quantitative data. So generally speaking, if the data is non-numeric, we'll call it qualitative. If it's numerical, we'll call it quantitative. So let's take a look at an example and see how this works. So let's determine whether the data is qualitative or quantitative. First, the ranking of service, whether it's excellent, good, or poor, at a suburban restaurant. Well, we can think about that there. All the solutions, all the data would be these three words. So that would be an example of qualitative data. Data which can be, we can count how many of them there are, but that's the only kind of arithmetic we can do with them, so to speak. How about part B here? The salaries of the wealthiest 100 CEOs in America. Well, those salaries would be numerical in nature, so that is an example of quantitative data. Data which is computable. You can do the four operations: addition, subtraction, multiplication, and division. Now, we said in this section and the next section we're going to talk about graphical descriptive statistics. So the first graph we want to talk about is the bar graph. Bar graphs are a type of graphs used to give a graphical description of categorical data, and this data is grouped into categories called classes. And the number of data items into each of these categories is that class frequency. The most common type of bar graph that we'll talk about in statistics is called the Pareto chart, named after the Italian economist. And we can graph bar graphs and Pareto charts online at the site hosted by the National Center for Education Statistics called Create-A-Graph. And if you look in your Blackboard site, under course content, you have a link to Create-A-Graph, and we'll see how that works here in a few minutes. Now let me give you some of the properties of Pareto charts, because they're a little bit different from what you might think. First, the horizontal axis, the one that goes left and right, that contains the labels, the quantitative data values. The vertical axis is labeled with the frequencies, the number of times each of these qualitative data values occur. The data is arranged from largest to smallest in frequency from left to right. So the class that has the most quantitative data values goes first, and then the second largest one goes second in terms of its frequency, all the way down to the smallest one, which is on the right-hand side. The height of the bars is used to determine the frequency of each qualitative data value, and the values have equal width and an equal space between them. And a graph like this should include an axis and a title. So let's take a look at an example here and see how we can make one of these Pareto charts. So in 2014, 11% of Americans had attained an associate's degree, and the data in this table shows the highest level of high school mathematics taken by the students attaining this degree. So now these don't add up to 100, because you can think of different people whose highest mathematical course was Algebra 1, then got a certificate, some got a bachelor's degree, some got a master's degree, and so forth, all right? We want to make a Pareto chart of this data. So let's go ahead and get that started. And now I'll use the Create a Graph site, and we'll just kind of go through it and see how it works. So notice the most frequent class is pre-calculus, 16.6%, and then it's trigonometry, and then it's calculus, and then algebra 2 and algebra 1 is last. So let's go ahead and start that. So I just go to our class site, click on the link to create a graph, and we want to click on bar because we want to make a bar graph. And we'll click on the data tab, and we'll go ahead and put in the title. I'll just call it highest level of math course. And now let's see, it looks like we had 5 different classes. So I'll put items at 5, and let's go ahead and put those in. Now remember, we wanted the one that's the most common to go first. That was pre-calculus, and that value was 16.6%, so I'll fill that one in. And the next one was trigonometry, so I'll put trig, and that value was 15.9%. And then the next one is the calculus students, and they were at 14.9%. And next was algebra 2 at 9%, if memory serves. And then the last one was algebra 1, and there were 7.4% of folks who took that. So notice we've listed these from the most frequent to the least frequent. And now if I click on preview, you can get an idea of what the Pareto chart would look like. So there it is, and we can dress this up a little bit. I always like to make these font sizes bigger so that we can see what's going on. So I did that under the labels tab. Now if we preview it again, we can see things a little bit better. So you can see the power of the Pareto chart. We can immediately tell what the most frequent class is, and that's by just looking at the left-hand side. We can tell the smallest class by the data value on the right-hand side. So that's how we can use Create a Graph to make a Pareto chart. Now let's take a look at that. Now let's get back to the Pareto chart and just make a few observations on it. There's the Pareto chart we just made. First, the number of groups in which the data is classified. I've used this term before. They're called the classes. So notice here in this case we have 1, 2, 3, 4, 5 classes. We have 5 bars. The number of data items in each class is its class frequency. All right. So the frequency of the first class here is 16.6%, 15.9% for the second one, and so forth. The sum of the frequencies gives the sample size. All right. So if we add up all of these frequencies, we get the sample size, and we'll denote that with the lowercase letter n. And to state that mathematically, n is equal to, well, this Greek letter sigma, that means the sum of. So the sample size is equal to the sum of the class frequencies f. The relative frequency for each class is given by the frequency of a class divided by the sample size. All right? So those are some observations we can make on a Pareto chart. Now let's look at another kind of chart that I'm sure you've seen before, called the pie chart. Pie charts are very common, and they're not used in statistics a whole lot. Pareto charts really are used in lieu of pie charts, because they're a little bit easier to read and to understand. So a pie chart is suited to show how a whole quantity is divided into several parts. The pie chart is divided into slices, like a pie, and they're called sectors. And the measure of each of these sectors has a central angle given by, well, here's how we compute it. We take the category frequency, in other words, the relative frequency, and divide it by the sum of the frequencies, in other words, to get the relative frequency, and multiply it by 360. Take the frequency of a class, divide by the sum of the frequencies, that gives us that relative frequency we were talking about earlier, and then multiply it by 360 degrees. Now here's some properties of pie charts you may not know. First, a pie chart shows the parts of a whole for each qualitative data item, each categorical data item. And the sector is labeled and includes its frequency or its percentage. And the circles are arranged with the largest in the upper right corner, and then they go in descending order as we go clockwise around the pie chart. So let's take a look at an example of one of these and see how we can make a pie chart for it. So how about this? The distribution of the U.S. population classified by blood type is shown in the table. So there are 4 blood types, A, B, AB, and type O. And so 40% have type A, 11% have type B, and so on. And so we want to make a pie chart of this. And let's make a note here, and this is a pretty important note. This kind of table that we see has a name. It's called an ungrouped frequency distribution. All right? Whenever we see the word distribution in statistics, we mean a table. So this is simply a frequency table. And it's ungrouped because we have qualitative data, and we'll talk more about a grouped frequency distribution in the next section. So let's see how we can make one of these pie charts using Create a Graph. So I'll go back to my Create a Graph site again, click on Design, and now we want to click on the pie chart. And we'll go ahead and put the data in. And in this case, we want the blood type. And we have 4 classes for the 4 different blood types. And we'll just start filling these in. The one that was most frequent was type O. That's our most frequent blood type. And we have 45% of the population for that. And then our next blood type is type A. And type A had 40% of the population has type A blood. And then the next most common is type B. And we saw from the chart there that 11% of the population had type B. And then the rarest type is blood type AB. And we saw that only 4% of the population has type AB blood. So we'll go ahead and, here, let me make these labels a little bit bigger. They're both 22 point, that'll be okay. Click on Preview here. And there we see the different blood types. Now we can go ahead and mess with the labels here. So if I click on Label, we'll put on percent of total and label. Now if I click on Preview again, we can go ahead and see here that here's the largest blood type in the upper right corner, so to speak, type O, and then 40, and then 11, and then 4, type AB, the smallest blood type. So we want to arrange them that way. And that's how you make a pie chart using Create a Graph. So let's get back, and now you'll never have to make one of these, by the way, on a test or anything, but what you want to be able to do is to analyze it. So let's do this. Here's the pie chart we just made. Let's answer a couple of questions about it. First, what's the rarest blood type? Well, that'd be type AB, isn't it, right? And that's because it has the smallest of those relative frequencies. Next, what two blood types constitute 49% of all the blood types? Well, let's see here. If we take type O, it has 45%, and add that to AB, that's 4%. Well, that sum there would be 49%. So it looks like the blood types that constitute 49% of all the blood types, that'd be type O combined with type AB. So there we have it. That's how we graph qualitative data.